Bundan sonraki son sorumuz biraz iş sağlığı güvenliği ile alakalı. Kömür üretme proseslerinde hepimizin bildiği gibi patlama riskleri ve yanma riskleri her zaman maalesef mevcut oluyor. Önlemleri alsak da. Diğer taraftan alternatif yakıtlar işin içerisine girdiğinde toz patlaması riskleri bir miktar daha artıyor. Bu bazda da tabii ki bu durumda da iş sağlığı güvenliği açısından daha fazla odaklanmamız gerekiyor. Bununla alakalı bir konu olan sunumu var Sayın Bertolt Uzbeki'nin. Kendisi son sunumumuzda kömür ve ikincil yakıtlarda toz patlamalarına karşı koruma başlıklı sunumunu yapacak. Torvens'ten Vent Satış Direktörü Bertolt Uzbeki'yi sahneye davet ediyorum. Buyurun. Hayır,
All right. Thanks a lot for the nice introduction. So, ladies and gentlemen, a warm welcome also from my end to the afternoon session in terms of 3 presentations. So, my name is Bertolt Busivike and I'm representing the company Torvest and Wendt. So, we are a German-based company and we are involved in explosion protection technology since more than 30-35 years. But right from the beginning, I want to point out that our technology is different to the so-called conventional explosion protection technology. You may know these kind of bursting panels or rupture discs, which are somewhere installed and used in explosive areas like silos, storage silos, or coal mill backhouses or whatever. So we are doing that completely differently, and this is the technology what I would like to bring a bit closer to you. We are doing this in a so-called self-reclosing mode. That means after the explosion has been vented in the atmosphere, the system is kept closed automatically, and in addition to that, these kinds of explosion venting devices are reusable. That means you do not need any exchange of the entire system itself. So this presentation, as shown here, is focused on the protection of coal handling, coal storage, coal grinding, and of course secondary fuels. So we have already heard a lot of explanations, especially by Mesut, concerning substitution. This is definitely the right way into the right direction to substitute fossil fuels by alternative fuels. But we should not forget that coal as a burner fuel still plays an important role in the cement industry. In Turkey, even in Europe, but worldwide definitely. So this is our issue today, and now I would like to start now with the presentation with this first slide, bringing this issue a bit more closer to you. So this is just a list, statistic list of the second quarter of this year, showing you 64 recorded incidents, and they are divided in 11 combustible dust explosions, 39 combustible dust fires, and 40 potential combustible dust incidents. So, and we are definitely of the opinion that reliable explosion protection, in order to minimize the impacts and the negative consequences to a certain extent, are definitely required. And this is our target. We want to minimize the risk to a certain extent. You see here also that 7 of these 64 incidents reported injuries, and this is very sad. Even 12 of those injuries required hospitalization, and this is sad as well, of course. Here, I would like to show you some pictures, what may happen in case of explosions or fires if the protection system is not working well. So on the left side, you see 2 coal mill back filters of a coal grinding plant. The explosion in this case started in the back filter, mainly in the hopper of the back filter. And this picture here on the left side, where you can see these open flames here, this is demonstrating very clearly what happened. this filter has been equipped with rupture panels. Of course, they do what they should do, but they rupture and they remain open. And the back filter is always having a kind of chimney effect. That means the fire, what comes always along with the coal dust explosion, is going to be fanned heavily. And you may believe that this kind of fire cannot be extinguished by the fire brigade. That happened very often. So in this case, you can stand in front and wait until the fire is burned down. But this is not the issue. The issue is to protect such filters seriously in order to minimize the risks to a certain extent. Here, wood chip silos, referring to alternative fuels. There was an explosion in this, we call it domed roof silo, without any protection existing. And on the right side, dried sewage sludge. This is also very common currently in terms of substitution of fossil fuels by alternative fuels. In Germany, we have a lot of projects. In Turkey, some cement plants are already using dried sewage sludge. But keep in mind that most of these alternative fuels, most of them, they are going to create explosive atmospheres, and protection measures are required in terms of explosion protection by venting as well as by preventive explosion protection measures. Here, these are the biggest enemies. So we call it enemy because on the right side you see this is a chemical oxidation process. What happened in coal yards, this picture I've made in Asia somewhere, and due to the high volatile content of this coal starts already burning at the coal yard. Due to this absorption of oxygen, this kind of self-ignition process starts, what ended up in a so-called smoldering fire. And the picture on the left side, this I've made some years ago here in Turkey, where I had the chance to look into the mill. This was a horizontal ball mill, and this kind of smoldering fire was directly transported by certain belt conveyors directly into your grinding system. And these smoldering fire, may act as a potential ignition source for an explosion. So this is really quite dangerous. Yeah, reliable explosion protection concept consists of two different individual working systems. So first of all, and this is my part from Torweston, this is the construction explosion protection by means of venting, self-reclosing devices, reusable devices. The other part, and this is covered by our partner company, the company Robeco, this is referred to the preventive explosion protection in terms of monitoring, control, and inerting system. So both systems are representing state-of-the-art explosion protection. Don't get me wrong, it's not a question either or. Both systems are representing state-of-the-art protection for such kind of applications. Yeah, construction explosion protection, just a brief introduction. What does it mean? Self-reclosing. Here the gray cover, this is the frame of our explosion door. The black one, this is the hinged lid, and the gray one, this is the baffle plate. Usually it's closed. If a certain activation pressure is exceeded, the hinged lid is going to open. Kinetic energy is absorbed by this air cushion principle and the baffle plate, and finally the lid is pushed back into the closed position and is kept closed by certain retaining devices. This is the basic principle of our self-reclosing explosion venting devices, to keep the system closed. All the equipment, what we are going to deliver to the market is ATEX certified, completely, the whole program. That means we have to approach a notified body in order to get it certified. This is an independent authorization doing this kind of test for us in accordance to the latest ATEX directive 2014/34/EU. This is mandatory. This is mandatory in order to make sure that this kind of equipment is working properly. Non-tested equipment you cannot be sure that the system is working properly. And to be honest, I have to admit there are so much copies on the market, black copies on the market, not ATEX certified. And from my point of view, they are not trustable. So because they haven't been tested. And the test procedure is very strict in this regard. What we are doing in terms of coal grinding plants is shown here. So this is a typical sketch of a coal grinding plant, which is divided into three sections. So the first section I want to explain is the ductwork protection. And here in this case, we are talking about a physical phenomenon, what is called flame front propagation in ducts. And that needs to be mitigated accordingly. And therefore, Torwestern has invented some years ago a special system in order to mitigate this flame front propagation effectively. And this concept, when we are talking about vertical roller mills, as shown here, consists of two independent working venting devices, when one to be positioned very close to the mill outlet, and when one designed and positioned in front of the backhouse, designed as an explosion diverter. So the principle is as follows. In case of an explosion in the mill body, it was analyzed from our end that the pressure, the existing pressure, created pressure in the mill body may reach a value up to 2 bar G. You may remember coal dust explosion comes always along with a fire. And now the phenomenon starts that this pressure of 2 bar G created in the mill is going to push the flame body into the riser duct. And the longer this riser duct is, the higher the velocity and the higher the pressure peaks at the end of this duct. That means everything what is connected to the duct at the end of this duct is going to be blown away because it is exposed to so tremendous forces and pressure peaks it cannot withstand. It is blown apart. Therefore, the first venting device, called vent number 1, is very decisive with regard to get rid of the explosion pressure created in the mill body. Very decisive. And when we are invited for audits to several plants, these venting devices, honestly speaking, always missing. That means the whole flame body is pushed towards the backhouse with definitely negative impacts in case of an explosion in the mill body. Therefore, effective mitigation of flame front propagation in ducts assured by the installation of these invented concept vent 1 and vent number 2. The second area is the explosion venting devices, calculations, protection concept for the backhouse. So in this regard, we have invented rectangular explosion venting devices, also of self-reclosing technology. And this design, believe me, is very complex as we have to consider certain rules. And the rule is giving us certain mandatory requirements, what kind of things and consideration needs to be considered. Therefore, we are always requesting our customers to provide us a GA drawing, the pressure shock resistance, number, length and diameter of sleeves, etc., as all these information are needed for a proper design. Area number 3, this is the pulverized coal silo. For this storage of coal, we are offering engineering for local manufacturing, and we are offering explosion venting devices designed in accordance to the needs. In most of the cases, and this is given by the rule, the venting area or the size of such a venting element is determined by the volume, what needs to be vented, as well as by the coal characteristics of the coal. You may know these values, KST and Pmax value. These are very decisive values in terms of the calculation. Of course, compliance with relevant rules. The DIN EN is very important for us, as well as the American rule NFPA 68. NFPA stands for National Fire Protection Association 68. Here, and this is nice to show, This is a reference, a new clinker line here in Turkey of 9,000 TPD per day. And we just delivered the complete ductwork protection. Here you see vent number 1 as well, vent number 2. The backhouse protection in strong accordance to the needs, based on rectangular explosion doors. And in addition to that, the coal silo, the protection for the coal silo, including the complete engineering for these coal dust silo to be manufactured locally. New building. So retrofit, and this is also very important because we are very often required to come over for audits, invited for audits in existing plants. We are taking pictures, we are going through the plant, and then we are providing our customers with certain reports. We put the finger into the wound, telling them, here are the weak points, here you need to refurbish, here you need to revamp. And finally, this is one of our latest orders we have been received here in Turkey for certain ductwork protection, coal silo protection, engineering of 2 new flat roofs because we found out that the pressure shock resistance of the existing silos is not sufficient anymore. Dedusting filters for the coal silos, etc., etc. This order is currently under processing, under order processing. Yeah, last but not least, I have to mention definitely also the substitution of fossil fuels by alternative fuels. And one major fuel, what is currently very often used, is called dried sewage sludge. And dried sewage sludge may and can create dust explosions if the so-called dry substance content is above 85%. If the moisture content is bigger, then the users and the owners, they have to fear gas explosions due to the emission of CH4. You see it here. That happened already. Therefore, the composition of the dried sewage sludge is important to know. This is really important to know. Here we have some basic figures in terms of minimum explosive concentration. 60 grams per cubic meter are definitely enough in order to create a dust explosion. This deflagration index, I just mentioned, KST, is about 90 up to 190. Maximum explosion pressure, 8.5 bar. Here, this is an example, what we have conducted together with our sister company, Torwest and Silo Manufacturing. This is a silo delivered to a German cement producer for 500 cubic meter dried sewage sludge, including necessary explosion protection by self-reclosing explosion venting devices and dusting filter, heat point, etc., etc. Completely delivered by Torwest. Yeah, so now we come to the end of this constructional part. Some basic advantages of this self-reclosing mechanism. There is no ingress of air, of fresh air into the system because we are keeping the system closed. There is no egress of carbon dioxide or nitrogen in terms of an inerting system. And this system is reusable. No need for any entire exchange, and there is no direct contact between a possible fire in the system and the system's environment. So these are the major advantages. Coming now to the preventive explosion protection by means of monitoring and control as well as inerting. And we are working very successfully together with a company, with our partner company called Robeco. And by the following slides, I just want to explain you the system, how it works. So first of all, I want to mention some regulations. And this first one, the CEN TR 15281. This is now converted, transferred into an official rule. Before it was a guideline, and by the help of the Robeco engineers, the committee invited Robeco in order to take part in this revision. By the help of Robeco, now these guideline, in future it's called a DIN norm, has been now closed and finished. So technical issues have been completely closed, and it's now transferred into an official rule called DIN EN 15281. The next one, of course, this is ATEX. So even ATEX is applied for all equipment in terms of monitoring, analysis, etc. All equipment what is in contact with explosive atmospheres need to be ATEX certified. Yeah, total safety system. This is a description what comes from the ATEX directive, and it comprises the gas analyzer as a monitoring system, the protective equipment in the form of an inerting system that might be nitrogen or carbon dioxide, and in addition to that, you have to have certain control units in order to monitor and control the entire system. This is the meaning of a total system under ATEX. Very clear. Here, this is the control principle, a short sketch showing different measuring points. You see these red lines here. These are the measuring points that might be at the entrance of the mill, at the backhouse, at the outlet of the backhouse, or even directly at the silos. And all these measuring systems are giving their data to a so-called secure system. This is an external secure system in order to monitor and to control all these technical values which are coming from the process. That means if there is a certain value in terms of oxygen or carbon monoxide increasing or exceeding a certain value, the system, in terms of an automatic or in terms of an injection of inerting gas, is automatically activated in order to inject gas, inert gas, into the system. This is the control principle. There are two, call it design methods, two tank methods available. First of all, on the left side, you see the CO2 low pressure system. It comprises of a tank, carbon dioxide tank, and an ambient evaporizer in order to transfer the liquid CO2 into a gas phase before this is injected into the entire system. The operating pressure of this low pressure system is about 20 up to 23 bar. On the other side, you see this vertical tank. This is a high pressure system. What is with an operating pressure of about 50 up to 68, 70 bar. The decision what kind of system is used for different applications mainly depends on the ambient temperatures on site. So when we are talking about high temperatures with low minus temperatures, the low pressure system is preferred. If we are talking about normal temperatures and negative or minus temperatures, the high pressure system is preferred, but needs to be decided together with the customer. This is the reference of Robeco in Indonesia for Indocement, owned by Heidelberg. And so some years ago, these P14, line P14 has been built and completely installed with an inerting system, including the control and monitoring system. But nowadays, you see here all these lines P1 up to P4 and P6 till P11 have been retrofitted, have been revamped completely. And in total, Robeco delivered 6 complete inerting systems, including control and monitoring equipment. Yeah, so this was my contribution in terms of explosion protection for any kind of explosive media, like coal and alternative fuels. I would not forget to mention that we have also a booth here. This is booth number 60. And in Turkey, both companies, Torwestern and Robeco, are represented by the company Santa Sanay. Mr. Mehmet Pala, you may know him. He is also present. Means in case of any further assistance, question or whatever, feel free to contact us. We would be pleased to talk to you face to face. Thank you so much.
Thank you, Mr. Buzweke, for your presentation. Konuşmacılarımız güzel sunumlarını bizimle paylaştılar. Soru cevap bölümüne geçiyoruz. Sormak isteyen değerli bir katılımcı, herhangi bir katılımcımız varsa lütfen söz alabilir. Dear participant, if you have any questions about this valued presentation, you can ask. Peki. Teşekkürler. Thanks for all these valued presentation to dear valued speakers. Thank you. Şimdi bir molamız var, kahve molamız var. Bilim Makine sponsorluğunda olacak kahve molamıza davet ediyorum. Sonrasında görüşmek üzere ikinci seansta. Hoşçakalın.